Hello, welcome to today's lesson. Today we are going to look at the hyperbola. The hyperbola, right? So the general form of a hyperbola is y equals to a over x minus p plus q, whereby the p and the q represents what we call the asymptotes. So the p and the q represents the asymptotes. Now, what are the asymptotes? An asymptote is a line of which the graph goes closer and closer to it, but it never touches it. So in other words, it can be either a vertical asymptote or a horizontal asymptote, right? So the graph goes closer and closer to this line, but it never touches it. So as long as it goes closer and closer and never touches it, so we call this line an asymptote. So this is an asymptote. It's a horizontal asymptote, this one, and this is a vertical asymptote. So the P and the Q represents those asymptotes, right? So now we are going to look at this hyperbola where the P and the Q represents the asymptotes. Now we are also going to look at the shape. The shape of a hyperbola, if these are our asymptotes, we must either have it in the first quadrant. We draw it in the first quadrant and in the third quadrant of the asymptote, or it can be drawn in the second quadrant and the fourth quadrant of the asymptote. Remember, the axis may be anywhere, so we can have the axis anywhere. It doesn't matter where the axis may be, but then we are talking about the first and the third of the asymptotes. So we can have the x-axis here and the y-axis here. For this one, we can have the x-axis here, the y-axis here. It doesn't matter, but then we are saying the first and the fourth of, the first and the third of the asymptotes, or the second and the fourth of the asymptotes. So that's how we draw our graph, so, or the shape of our graph, right away. We are going to go to graph sketching. So we are going to look at the graph of y equals to 4 over, let's say, x minus 2 minus 1. Right, so this is a hyperbola. We are going to draw this graph, the graph of y equals to 4 over x minus 2 plus 1. So the first thing that we calculate when we sketch a hyperbola is to calculate the asymptotes. So the equations of the asymptotes will be x equals to 2. We just take the 2 to the other side, so it becomes a positive. So in other words, if this 2 was positive, it will be negative here as we solve it. So, and then y, because it's already this side, so we just take it as it is, so it's a negative 1. Right, so these are the equations of the asymptote. So this one is the vertical asymptote, and this one is the horizontal asymptote. So Right, so now we start with the asymptotes. The equations of the asymptotes, it's x equals to 2 in this case, y equals to -1. And after the asymptotes, the equation of the asymptotes, all we need now is the intercepts, the x-intercept and the y-intercept. So let's calculate the x-intercept. So let's start with the y-intercept. Y-intercept, we know that the x value is 0, therefore the y equals to 4 over, so where there was x, we'll put 0 minus 2 minus 1. Right, so this is giving us 4 over -2. It's a -2 minus 1, it's a -3. So our y-intercept is at -3. So the x-intercept, we know that the y value is 0, so we will have a 0 on y, and we will have 4 over x minus 2 minus 1. Right, so we are solving for x. We'll take the x this side, so we'll have -1 becomes positive because it's negative. When it comes this side, it will be positive. So we have 4 over x minus 2, and then we can multiply both sides by x minus 2. So we will have x minus 2 equals to 4 as we cross multiply there. Right, taking the 2 that side, obviously the x value will be 4 plus 2, which is 6. So we have our intercept at a -3 for y and then 6 for x. Right, so now we are ready to draw our graph. Right, so let's start with the axis. Let's start with the axis. So this is the x-axis, this is the y-axis, so we have our 0 there. Right, and then now we can go to our asymptotes. We go to our asymptotes. Remember, we said our asymptotes are at x equals to 2 and y equals to -1. So x equals to 2 somewhere there. So there is our asymptote. Right, and then y equals to -1 somewhere there. Right, so these are our asymptotes at x is 2 and at y is -1, the vertical and the horizontal asymptotes. Right, now we are ready to draw our graphs, or our graph. So the intercepts, the y-intercept is at -3, the x-intercept is 6. So x is a 6, x is positive 6. So the graph is intercepting the x value at 6 and the y at -3. So we have the y at -3 somewhere there. This is not drawn to scale. All right, so we know that the value of a is 4. So we said when it's 4, then it's in the first and third quadrant of the asymptotes. So in the third quadrant it will be like that, and in the first quadrant it will be like that. Remember, these are the asymptotes. So this is our graph. So that is how we sketch the graph. We said this is the graph of y equals to 4 over x minus 2 minus 1. Right, so this is our graph. This is how to sketch the graph. So the next thing that we are going to look at is how do we calculate the equation. How do we calculate the equation? So we are now looking at the issue of the equation of the function. So we must have at least the asymptote and 1 point. So suppose we are given this asymptote and we have this point here, let's just take the point at A. Now the coordinates of A are 0 and -3. So the x value is 0 there, and the y value is -3. So we know we have our asymptote at x equals to 2 and y equals to -1. Right, so with this we can be able to calculate our equation. So we will say the equation, we start with the form is a over x minus p plus q. All right, so let's start by substituting the p and the q. Right, the p excuse me, so the p it's 2 and the q it's -1. Right, so this is our equation, and then we want the value of a, so we'll substitute our point a, which is at 0 and -3. So the y value is -3, and then we're looking for this a, and the x value is 0, -2, -1. So we are going to solve for x. So we take the 1 to the other side, so it will be -3 plus this one here, so which gives us a -2. So this will be a over -2. 0 minus 2 is -2. So we can multiply both sides by a -2. We multiply both sides by a -2, so we get a to be 4. So now when we have a to be 4, so we can now substitute it here on this equation. So we have our equation as y equals to, now we put a to be 4 over x minus 2 and then -1. So that becomes our equation. Right, so the next equation that we may be asked to calculate is the equation of the axis of symmetry. The axis of symmetry. Axis of symmetry. The equation of the axis of symmetry. Now, what is this symmetry? Symmetry is a line that divides a function or graph or anything into two equal parts. So for example, if we want to divide letter A into two equal parts, so we will have a line. So see, this is our line of symmetry. Or if we want to divide the letter H into two equal parts, so we can either have this line here or we can have a line there. So those are the lines of symmetry. Now with our graph, we want the equation of the axis of symmetry. Now if we have this function like this, remember these are the asymptotes, not the axis, not necessarily the axis. So if we have this graph like this, we realize that to divide our graph into two equal parts, we can either divide it this way, so this part down there is the same as this part down there, or we can divide it this way. So we can have a line here, so this side equals to that side. Hence we realize that we have two lines of symmetry. We have two lines of symmetry, so we are going to have two equations because we can divide it into two. Right, now to calculate the equation of the axis of symmetry, we need to understand that it's a straight line, so m will be either positive or -1. Remember there are two lines, so the gradient will be -1 or +1, whilst the point, remember when we want the equation of a straight line, we need a point or and the gradient. So the point will take our asymptotes. Do you still remember our asymptotes? So if we said our graph is 4 over x minus 2 minus 1, and we have the asymptotes at 2, and then the y value we said is -1. So it means if we need a point, the point will be 2 and -1. So now we are going to calculate the equation of the axis of symmetry. So the gradient is +1 or -1, and the point is at the asymptote, which is 2 and -1. So calculating the equation, we can use the simple equation of y equals to mx plus c. So substituting everything, the y value is -1, and the m, let's start with the positive. The x value is at 2 in this case, and then we have plus c. Right, so 1 times 2 is 2. So when we take the 2 to the other side, it will be a negative. So it's -1 minus 2, which is a -3, giving us the c value to be -3. And therefore we can substitute and get our equation. So the equation will be y equals to 1x, and then the c, it's -3. So the first equation will be the line y equals to x minus 3. Right, the other one, now we substitute the m with a -1, so we do the same, and we have y equals to, okay, we have the y equals to the mx plus c. Substituting y, it's -1, and then m, now it's -1. All right, and then x, it's 2, and then we are looking for the c. So now a -1 times 2, it's a -2, and so we take it to the other side, it's going to be plus. So -1 plus 2, it's 1. So giving us the value of c to be 1. So if we substitute everything there, our equation will be y equals to, now it's minus, the m is -1, so it's -x plus 1. So if you can see, we have the one with a positive gradient, and the one with a negative gradient. Hence we said we will have two asymptotes, the one with this one with a negative gradient, and the other one with a positive gradient. So this is how we calculate the equation of the axis of symmetry. So they may ask you to calculate the equation of the axis of symmetry. So if they have marks, they can ask you to get them both, but if they don't have marks, they can ask you to get one of them. So just check whether they say the one with a positive gradient or the one with a negative gradient. So but either way, they will ask you to calculate the equation of the axis of symmetry. Right, the second thing that I want us to look at is to rewrite the question of rewriting, because they can give you the equation in different way. Let me give you this form. Let's say you have x plus 2 divided by x minus 3. Now when you look at this, it doesn't really show us that it's a hyperbola, but it's a hyperbola. They can give it to you this way and say rewrite it in the form y equals to a over x minus p plus q. So we are going to rewrite this equation here in the form, in the normal form. Okay, so I advise you to look at the denominator, and where you see x up there, put the x in the denominator. So in other words, because we see x, we just replace it with x minus 3, so that we have the same thing with what we have at the denominator. But look, because this is now over x minus 3, so but if you check, now we have changed the numerator. So we want it to go back to where it was. So remember, we have a plus 2. So we have x plus 2. So in order for us to have a plus 2 here, so we have to actually add something. Now, so minus 3 plus something should be plus 2. So you can even work it out and say x minus 3, or not necessarily with the x. So you can even take out to take away the x. You can say minus 3 plus something. So that's something. You can even say it's x to make it easy. So minus 3 plus x should be 2, because we want a 2. So we can now solve for x. So we'll say, oh, x is, now the 3, when it goes that side, it gives you a 5. So you'll say 2 plus 3, which is 5. So it means we are adding a 5. Right. So in other words, if you work the numerator now, you'll go back to x plus 2. Now, in this case, you can now rewrite this equation as x minus 3 divided by x minus 3 plus 5 divided by x minus 3. Right. So you can now write this like this, because if you want to go back, you can just find the LCD and it will give you back the one on top there. Right. So then you can now say, okay, x minus 3 divided by x minus 3 is 1, and then this is 5 over x minus 3. So that is your equation. So now you can see that your equation is 5 over x minus 3 then plus 1. So you can rewrite it that way. So let's maybe take something a little bit more complex than this. So let's say we have y equals to, let's say we have 3x minus 1, and this is over x plus 2, and we want to write it in the form y equals to a over x minus p plus q. Now, I said that the first thing that we do, where we see x in the numerator, we replace it with x plus 2, the denominator there. So that is the first thing that we need to do. So the first step will just to be y equals to 3, and then we see x, so we'll write it as x plus 2. All right, and then over the x plus 2 there. Now we want the minus 1. Right, so we can do some little calculations here, because now we see that when we multiply, we'll get 3x plus 3 times 2 is 6. So we will have a 6. Now 6 plus something, let's just say x. So it must give us minus 1. So 6 plus something must give us a minus 1. So if we take the 6 that side, we realize that that plus something would be minus 1 minus 6, which is negative 7. So in other words, we need to subtract a 7 there. So now we have our equation as y equals to 3 into x minus or plus 2 over x plus 2, then minus 7 over x plus 2. So we can separate this, and then as we separate, you can see the x plus 2 will cancel out the x plus 2. We will have 3 minus 7 over x plus 2. So there is our function. That's the graph we wanted. So we can write it nicely and say this is y equals to minus 7 over x plus 2 and then plus 3. Right, so we have now written it in the form y equals to a over x minus p plus q. Right, so this is some of the things that you may be asked to do. Okay, the next thing that I want us to quickly look at is the domain and the range. So let's look at the domain and range. The domain and the range of a hyperbola. Right, so to get the domain and the range, remember we said the domain is the x values that are covered on the graph. So now looking at the hyperbola, all x values are covered, so we'll just write x is an element of real number. So as long as it's a real number, it's covered, but there's only one particular x value that is not covered, so we'll just say okay, accept that particular x value, and the x value is at p, meaning it's at the asymptote. So in our function, remember, let's look at the function, or the equation that we had, where we said it's 4 over x minus 2 minus 1. Right, if we want the domain of this, we'll just say x is covering all real numbers. It does not cover 2. So that's the only value that is not defined on the graph. The 2 is not defined on the graph. So, but in general, as long as we know the p value, so we'll just say the domain x covered all real numbers except at the asymptotes. At the asymptote. So same thing applies to the range. Remember, with the range, we are referring to the y values that are covered on the graph. So it will be the same as the domain. It's just that now we are talking about y value. So we'll just indicate that y is an element of real numbers except the asymptote, which is q. So we just write it the same way. So in other words, in our function that we have there, so we will say y is an element of real numbers except that y should not be a negative 1. So all real numbers are covered on the y values, on the y, and x, with the exception of negative 1, because the graph is not defined at 1. All right, quickly I want us to look at the reflection. We will look at transformation. Let's do transformation. Now transformation, let's start with translation. So let's do translation quickly. Let's do translation. Now we said translation is shifting. So let's say we have a function. Let's take the one that we've been dealing with. So it's 4 over x minus 2 minus 1. And we want to shift, let's say we want to shift this graph. Let's say 3 units up and maybe 2 units to the left. Right, we want to shift this graph 3 units up and 2 units to the left. 3 units up and 2 units to the left. Now let's see what type of a function we are going to have. Right, so it means we are going to have y equals to 4 over, now x, right, for left and right it will be on x. So left and right is 2 units, so we have a 2 there, and then remember, then there is a minus 2, and then we have a minus 1. Now 3 units up, so we have a 3 for up and down. So this is for the y, or the up and down. Here it's for the left and right. So with up, it means we will have a plus. Now to the left, surprisingly, we also have a plus. Now, in other words, when it's on the equation, if they say to us go to the left, we must add, but if they say go to the right, we must subtract, so that when we work it out, we are able to solve it properly. So I can even say here that to the left we add, and to the right we subtract. Right, I'm writing this because it can be confusing. Sorry. They are saying to the left. So when they say to the left, generally our minds will be telling us that left we must be subtracting, but actually to the left we add, and when they say to the right we must subtract. But with the up and down, it's as the mind says. When they say up we just add, when they say down we just subtract. So there should not be any issues with the up and down, but let's be careful on this one. When they say to the left we must add, when they say to the right we must subtract, as long as it is on the equation. But if it's just a point, let's say there's a point A and we are transforming it. Let's say they say A is 2 and 3, they say left. In that case, if it's just a point, when they say left just subtract, and then right just add. So let's not confuse it. But if it's an equation, if it's on the equation, please let's remember, when they say to the left we must add, to the right we must subtract. So we need to remember that. So it means after doing this transformation that they told us here, the new equation will be y equals to 4 over x minus 2 minus 2 is 0, so it's fine, minus 3 minus 1 plus 3 is 2. So the new equation will be 4 over x plus 2. Right, so that is translation. That is the shifting up or down, left and right. Right, the next type of transformation that I want us to look at is the reflection. Now with the reflection, we will look at these 3 basic lines of reflection. So the line y, actually the y-axis, and if we write it as an equation, we'll say it's the line x equals to 0, or the x-axis, we are going to look at this one, or if we want to write it as an equation, we'll say this is the line y equals to 0. Right, so now we will also be looking at a reflection along the line y equals to x. Now we say this in the grade 12 language. We are saying we are actually calculating the inverse. Right, so let's look at the first one. So we still look at our function y equals to 4 over x minus 2 minus 1. Right, we reflect it along the y-axis. So when we reflect it along the y-axis, we need to remember that x changes the sign. So in other words, reflection along the y-axis, x changes the sign. So we are going to have the equation, the new equation as 4 over, so this is minus x minus 2 minus 1. Right, but normally we always want to see our x being positive, so we will have to rewrite it as 4 over, so we take out a -1 as a common factor, and then we have x plus 2, and then we have minus 1. So we will finally have the equation as y equals to 4, -4. If we divide 4 and -1, it will give us -4 over x plus 2 minus 1. So that will be our equation after reflecting along the y-axis. So this is a reflection along the y-axis. The reflection along the y-axis, or the line x equals to 0, whichever comes first, it's fine. Right, so let's do the next one. We're going to look at the same equation, but now okay, our equation we are saying is 4 over x minus 2 minus 1. Now we are reflecting it now along the x axis. Now when we reflect it along the x-axis, or the equation y equals to 0, we are going to have, right, the y will change the sign, so we will have a negative y equals to 4 over x minus 2 minus 1. So this, now we always want to have y as a positive, so we'll multiply by negative 1 throughout. So the final answer will be y equals to negative 4 over x minus 2, and then this will be plus 1. Right, that will be the reflection along the x-axis. Right, we need to check here. Somebody might be asking, why do we have only, when we multiply by negative, why do we have negative 4 up there, but it looks like down there there's nothing that is happening? Right, remember we are multiplying by negative, so I'm just going to write this part here that can be confusing. So if we multiply by negative, if we make it a fraction, we'll have a negative 1 over positive 1. So this is negative, sorry, it was a 2. Right, so it's negative 1 over positive 1. So this is a negative. So this, can you see, multiply by a positive, everything will remain the same down there, and then multiplying here we'll have a negative 4. That is why we have this type of a situation there. Right, so now I guess you understand why the denominator is not changing. It's because of what I just explained there. All right, so the next thing, now we are reflecting along the line y equals to x. So when we reflect along the line y equals to x, where we see, they will swap, x and y will swap. Where we see x, we put y. So in the grade 12 language, we say we are actually calculating the inverse. So we are getting the inverse of the function. If it's f, we actually show it by this symbol. So that's how we calculate the inverse. Right, so but in grade 11 we just know it as a reflection along the line y equals to x. Right, so we take the same equation that we have been dealing with. So it's y equals to 4 over x minus 2 minus 1. So the first step is to exchange x and y. So as we exchange x and y, we will have x equals to 4 over y minus 2 minus 1. All right, so we have to solve for y, so we can take the one that side. So we'll have x plus 1 equals to 4 over y minus 2. We are busy calculating the inverse. Right, so we can multiply both sides by y minus 2. So we'll have y minus 2 and then multiplied by x plus 1. We will be left with a 4 this side. All right, so remember we are solving for y, so we will divide by x plus 1 both sides. So we divide by x plus 1, so we are left with y minus 2 equals to 4 over x plus 1. Right, then now we can take the 2 to the other side. So our equation of the inverse will be 4 over x plus 1 then plus 2. Right, so this is the equation of the inverse, or the equation after reflecting the graph by the line y equals to x. So we will get that. So and then how can we do this as a shortcut? If we have, let's say, the equation y equals to a over x minus p plus q, and we want the inverse. So if we want the inverse, we'll just have the inverse as y equals to a over x Now the Q will come here and it will change the sign. It was a plus, so it will be minus Q, and the P will come here. It will change the sign also. It was a minus, it will be plus P. So let's look at whether how this worked. Remember, we had y equals to 4 over x minus 2 minus 1. So the inverse, according to what I'm explaining here, if we want the inverse, we'll have 4 over y equals to 4 over x. So this will come here with a changed sign, so it will be x plus 1, and this one will come here with a changed sign, it will be plus 2. And if you check, this is the same thing that we got there, right? So you can go straight to the answer instead of having all these many steps, but I was just showing you how we get the inverse, so you can just go straight to the answer and take it this way. Right, so that is the inverse. Right, so you can do, let's just take one last example of how we can calculate the inverse. So let's say we have y equals to 5 over x minus 4 plus 3. So if we want the inverse, straight away we will say the inverse is y equals to 5 over x. Now we are going to take this 3 with an opposite sign. It's a plus, so it will be a minus 3, and then we'll take the 4 here with an opposite sign. It's a minus, it will be a plus 4. So this is the equation of the inverse. So our inverse will just be like this. Okay, thank you very much. I hope you enjoyed this lesson. So please don't forget to like and subscribe. Thank you.